What a pleasure it is to introduce our next speaker from West Virginia. Gene is the Director of Projects in West Virginia Conservation Agency. So Gene, if you're all queued up and ready to go, let's have the West Virginia response to remedial and repair issues. Starting out with our great panel that we had already during our annual meeting. You're our next speaker. Are you all set, ready to go?
Yes, sir.
Okay.
All right. Good afternoon, everyone. We thought the panel discussion earlier was really good. It was good to hear from everyone's perspective about the dams that they have in their states. We're going to give you a look at what West Virginia looks like. And a little behind on the slides right off the bat. So we're going to give you a little snapshot of what the dams look like in West Virginia. Brian led into our 170 statewide. That's what it looks like. We do have 170 high hazard dams spread out north to south, east to west. This is a snapshot of what our dams look like that have expired evaluated lives. We have 170 total. We have just over 100, actually 102 right now. And we have 5 more that will be expired next year in 2022. Brian alluded to our maintenance costs. We spend right at $1 million every year. In 2012, we really took a hard look at the maintenance around the state as far as getting it, I'll say up to speed 100%, however you want to define it. There was a few years, 2012, 2013, we're probably a little over $1 million. It seemed like for whatever reason, we settle in pretty hard at $1 million every year. We pencil in $1 million. There's a chance we could get up to 30% back from local sponsors, but we don't count on that until we actually get it. This year we're running about $735,000. Some of the conservation districts are late getting their invoices in, but I would bet anything that we'll be back right at $1 million. So as we transition from normal maintenance to look at our repair program, one item that I wanted to let everybody see, that an issue that we have on a lot of our dams, is that we have a real heavy debris load, floatable debris. We have a lot of gas line exploration, mining activities upstream of a lot of our dams. The pictures that you see are all of the same dam. The debris load is heavy. The picture on the right is one cycle after the debris boom was installed. We did install a debris boom upstream of the riser. This picture shows 1 year from a clean out of the riser, the boom installed, and then the debris that was caught the next year. The debris load's the same, but just the ease of getting it cleaned out really cuts down on our costs. But that's sort of a good segue as we go from looking at our maintenance program to looking at our repair program. So after we got our arms around our repair program or our maintenance program, we wanted to look hard at what we considered repair, what we call repair in the state. So we broke it down into 5 categories: trash racks, tow drains, the concrete conditions of the principal spillway pipes, as well as the risers, slips and landslides, and seeps. We do have a lot of seeps we'll get into in our presentation. Because of funding, we had to prioritize each of these categories around the state. And it sounds crazy to have to prioritize seeps, but that's what we had to do just because of funding. So trash racks, we have 44 sites around the state that either have damaged, rusted, missing trash racks. These trash racks, are as old as the dams. We've never replaced any of these. Since I've been here, we've put some metal on a few in the past, but never wholesale replacement. So one of the tasks we wanted to look at is just have all the inspectors look at the trash racks. We were lucky a few years ago as far as the trash racks inspection goes. We had a decent drought. So a lot of the pools were low. So we were able to see all the trash racks, where at times we couldn't because of normal pool. So we had new trash racks fabbed up and galvanized. The right picture shows those trash racks, or at least some of the trash racks as they are being delivered. We're currently waiting on the delivery of those. That should come through in the next 2 to 3 weeks. And just because it drug out with the supply chain this year, that will be a 2022 install. But after we get these 44 installed, as far as trash racks goes, we'll be pretty good shape. Good. So tow drain outlet pipe replacement. These our tow drains are corrugated metal, which there's been a lot of conversation about corrugated metal so far today. We had 31 sites that either have damaged, rusted, missing, or tow drains that show up on the as-builts that we can't find. So we are doing a tow drain replacement to a point. We're not digging all the way back into the dam. We worked out some protocols with West Virginia Dam Safety. With me today is Levi Cypress, our engineer. Levi is going to talk to you a little bit about the protocols that we were able to work out with dam safety, so they would consider this a normal maintenance activity, not digging into the dam where we would need a permit. So Levi, talk to us a little about the protocols for this project.
All right, so the tow drains we looked at here to come up with these 31 are the sites identified easily with visual inspection or camera inspection to be likely damaged, separated, whatever, not very deep into the embankment. So working with dam safety, they allowed us or permitted us to dig 10 feet horizontally into the embankment to chase these tow drains, or 4 feet vertically into the embankment to the bottom of the tow drain to replace. So we're going back into the embankment, finding competent pipe, and either removing old couplings or cutting to install new coupling, but with Schedule 80 PVC and UV resistant pipe coupled and then backfilled with animal guards installed on the end of those. Will be in good operation as far as the outlet portion of those, which we're seeing as being a big a high number of these tow drain sites is at the outlet channel end of the tow drains.
Now, if there's any, obviously the goal here would be to find, competent pipe, good pipe as we dig back that 10 feet or 4 vertical feet, whichever comes first. If there's a situation where we do this digging and we reach our limit that we are allowed to dig, we're going to mark the pipe with stake, put the new pipe together with the old pipe the best we could be, understanding that we are hooking to a damaged or rusted pipe, and then further investigation would have to happen after that. So that's what's going to happen if we don't find competent pipe as we dig. But there are 31 sites that we're looking at to do this. So next we looked at slips and slides. Slips and slides around the state. A lot of the area that that these dams are built in are prone to slips, just as the nature of the ground around. The slip on the left is the inlet to the ASW on one of our bigger dams in Wheeling. And the slip on the right, the slip's actually sliding into the ASW. The one on the right was actually, there was a repair attempt in 2001. It stayed for a few years. Actually, you can look to the right of the circle in the right photo. You can see the repaired area, but the slip has come back in. It is entering the ASW. So these are both, the one on the right is under investigation, and we hope to go to construction next year. The one on the left is fairly new, so it's just starting down in the investigation. Then we have seeps. We have a lot of seeps in the state. We have 7 that are currently under investigation. The picture on the left is a picture that we've used in many of our presentations. This picture's been taken from Google Earth. It shows 5 defined seeps on the downstream slope of one of our dams. This dam has been through investigation, design, and was scheduled to go to construction this year, but now will be pushed to next year. But this one is ready to go. This one has sort of been our poster child to this point, to actually trying to get these seeps collected, drained off the dam. The one on the right will also go to construction next year. It's been through design and it's ready to go. It's just that we ran out of construction season. I'm gonna let Levi talk to you a little about some of the protocols that we follow, some of the cost saving measures that we're looking at and that we've been successful in as we've investigated these seeps, and how some of that investigation actually directs our some of these protocols direct our investigation.
So we've sort of developed a standard procedure that we've been working on in investigating these seeps. And usually it's some portion or combination of drilling, soil and rock sampling, piezometer installation, and dye testing, or potentially all of those in phases. But we've looked at a couple different sites here, this dam on the right being one of those. Started with dye testing, because what we're seeing with the dye testing, the money and cost savings potential we have in that ends up being in the order of hundreds of dollars rather than thousands of dollars for drilling and piezometer installation. So here we started with the dye testing, placed directly into the pool with receptors at the seep outlet to potentially confirm a connection from the pool to this downstream seep. We didn't have that here, so we moved into the drilling, like I said, sampling, piezometer installation, and then actually went back in with a little bit of dye in those piezometers. So if you can see my mouse here on the screen, this is obviously where the seep is, and with the pool behind us, the piezometers that we installed were toward the left abutment into rock. So we placed dye into those piezometers and actually had a connection from more toward the left abutment to this seep here. Another dam that we did dye testing on actually confirmed that we have a direct connection from the pool to the seep, which is one of the dams we're going to be ending this presentation with. And then dye testing planned on a third dam that we'll begin the investigation on.
So those are the categories that we tried to break down our repair program as we developed it, and what we looked at statewide. The current construction projects, or the active construction projects, is what we want to really dive into here. So we had the trash rack replacement, which I'm not going to talk about anymore. You've seen the pictures of that. That's really come together really nicely. And I will just mention that we built the trash racks off the original as-built with just a few modifications. That's what was sent to the machine shop. And then obviously they were sent out to be galvanized. And so that was the process. It really was that simple. There was no real change from the original design. And second, Brush Creek 4 and 5. So the Brush Creek 4 and 5 goes to our concrete repair, and that is actually the picture I used for this slide. Not only, it just gives you a good idea of what the risers look like, some of the bracing we had to use, but it also has the cleanest concrete truck that we've ever seen on site. So we thought that was pretty cool. But Brush Creek 4 and 5, and then Warm Spring 7, which was what we will close our presentation with, which started out as a seep investigation, turned into something completely different here. So let's just jump into Brush Creek 4 and 5. So Brush Creek 4 and 5, they were built and completed in 1962, designed in the 50s, obviously, probably started in 60 or 61, completed the same year, built at the same time, and surprised they had the same problem. So the problem is, the inspector reported what he thought was, hole in the riser. It was below the ordinary high water mark, or the below the normal pool. And I spoke earlier about the drought we had a few years ago. That allowed the pool to go down to the point where we could actually see these holes a little better. So we had to drain and do an investigation. I'm gonna let Levi talk a bit about the investigation, the design that went into just being able to expose the rebar, some of the work and bracing we had to work on to where the project stands today.
As Gene mentioned, this started with an inspection regularly with our inspector down in that area, and noticed that had some leaks below normal pool here. So we started with the camera inspection from the principal spillway pipe up into the riser, and could see that we had water entering the riser below the orifice at one of the concrete joints. So we decided we wanted to move forward. The dam would have to be drained for construction. So we drained it early in order to complete inspection. And that was a visual inspection and concrete sounding on the exterior portion, and initially just camera inspection on the interior of the riser. But that identified these areas of concern. So once we identified those, we started designing through consultants, and actually designed for the worst case. So I'll point out here the bracing that you can see in all three pictures, particularly on the first picture and the third picture here. So this allowed us, and was a big component of the engineering portion of this, but this allowed us to, if necessary, remove concrete 360 degrees around this construction joint. Now that would be done in stages, but half at a time. So a big portion of this concrete to be removed at a time. So we began removing the concrete, and just want to show the care that the contractor took into removing this concrete, and making sure we were not removing too much concrete and not damaging any rebar while we were in there. That if you can see this picture, they actually have the existing ties still on a lot of the rebar. So I thought that was pretty cool. But replaced some of the rebar there, and then poured the concrete, which you can see on the right there. And the contractor had a pretty slick design there, of a chute to that entered above the top of the void, and we could move concrete into place through vibration to make sure we had filled up that entire void, and ended up being 3 different spots that we opened, 18 inches top to bottom, and variation left to right of how big the area was, but 3 major concrete replacement portions. And to finish this job up, which is where we currently are this week, we are going to resurface the riser, or are resurfacing the riser, and resealing that. And finally here, to complete that construction 100% and delivers basically new product at the end of this, is for gate and hardware replacement. So you can see we had damaged or definitely deteriorated gates, stems, guides. And because of that, when we initially did the inspection and drawdown, I think we lost control. When we did inspection and drawdown, that we had to pump down. We couldn't operate these gates. So, if we have to do another repair 50 years down the road, we want to hope that we can operate these gates. And by doing that, we decided to try stainless gates on here to hopefully get us a little bit more life out of these structures.
Levi talked about resurfacing the riser. That's resurfaced inside and outside. The stainless gates, we got the idea from a consultant. We looked into them, and that's the way we're going to go. So we're sort of excited to see how this turns out. But the project's moving forward pretty quickly. We got a very good contractor. So that's Brush Creek 4 and 5. They're 5's just starting the construction part, but 4 was the worst of the two. So moving on, Warm Springs 7 that we mentioned earlier. Warm Springs 7 started as a SEEP investigation. It was part of the original 7 dams that we were doing investigation on. It had what was deemed a historic seep to the right of the principal spillway pipe and under the principal spillway pipe. The investigation was moving into design for a filter system at the point of the seep at the downstream toe of the dam. Early September, we had some rainfall and not a lot. It was an inch or two. It wasn't anything like was spoken about it in Mississippi, but the inspector the next day's out doing his inspection, noticed that the flow at the seep had really picked up, and there were sand deposits in the riffles under the pipe to the right of the pipe at the point of the seep. So we circled the wagons pretty quick, got dam safety over there to take a look at it. And we were advised to drain the lake immediately, drain the permanent pool. So that's really how that process began. This was September. I'll let Levi give a quick rundown of what we found and how we reacted to it.
So as Gene mentioned, it was recommendation from dam safety to drain this reservoir, to remove the driving head at this seep here to mitigate any further potential particle movement or whatever we had here at the seep. So you can see the top right picture here. We have our pumps similar to Brush Creek 4 and 5 that we removed about 9 feet of water. So not a huge reservoir here, but down to a drain pipe at the bottom of the pool, the deepest portion of the pool. And unlike Brush Creek 4 and 5 that did have a gate, whether operable or not, this one does not have a gate. It just has a plate bolted on the inside of the riser connected to this drain pipe that moves upstream into the pool. So we drained the reservoir and removed that plate, but we didn't have any water flowing through that pipe. So, a couple tries, a little bit of effort to try to remove any obstructions from that pipe or sediment at the upstream end of the pipe. We had no success. So again, with our pipe camera, we ran up this drain pipe and came to the first section that you can see in the top left picture of a separated drain pipe. And moving past that, this was about 7 feet upstream of the riser. And then another 20 feet beyond this section was another separated section that was actually much worse than this, with coupling apart and between the two pipes and rotated. So we had big problems with the drain pipe here. In order to drain the dam, we needed to run through this drain pipe. Otherwise, we'd be pumping and pumping and pumping. So our quick solution, temporary solution, was to slip line, as you can see in this bottom left picture, or sleeve the existing pipe with a new PVC pipe cemented in place, so we can allow the water to run through it into the riser and out the principal spillway pipe. And that's what you see, the finished product, temporarily, as you can see, which is what the dam looks like today. So this is the riser pipe at the end of the PVC that allows the flow to, like I said, go downstream and not impound any water there. So this was a temporary measure that we had to address, which was not, in a sense, was directly because of the seep we were downstream, but not, as part of any of the seep mitigation measures or repairs. So the more permanent fix, obviously looking at some sort of downstream improved collection system, chimney drain or filter diaphragm around the principal spillway pipe, some measure to mitigate the seep and particle movement there. In doing this drawdown, we found a number of other issues here with this drain pipe. Found a crack in the riser that was allowing water to move through, as well as some auxiliary spillway issues, being the changes in hydrology and PMP numbers that have come about since this dam's original construction in 1958. So the permanent fix, we're looking to go in and do a full repair slate. So at the end of this construction, we've got a pretty new, pretty healthy dam.
This is real time right now for us. We're looking at reviewing proposals as we speak. We have the whole watershed running through that slip line pipe right now. So obviously we have weekly monitoring. So this is our big project, and it wasn't planned to be a big project at this moment. So moving on, as I summarize, Ray's giving me a 5-minute. Brian referenced letters we got from dam safety. So, at this point, we're thinking we got Warm Springs 7, we got some seat designs ready to go, and then we get these letters. In West Virginia, West Virginia code states that there's a certificate of approval required to operate a dam. All right, certificate of approval to operate a dam. So right now we have 32 dams that do not have a certificate of approval. Here is the list of those if it matters to anyone. The only note I'll make to build on the conversation earlier today, if you look at the very right-hand column, most of these are 50-year dams outside their evaluated life. I don't know really what that means and how far that goes, but just point that out. I want to let Levi take 30 seconds and, administratively, we have to figure this out, but I want to give us 30 seconds to what that would look like on the ground, what per the letter of dam safety, not complete rehab.
Right. So the dam safety letters cite classification changes and deficiencies due to that. So as you can see, this entire list was designed as significant and have moved high. So what that looks like generally is the spillways for significant hazard dams were designed to pass about half of the PMP safely. Now that they are high hazard, they have to pass 100% of that PMP without overtopping or with adequate overtopping protection there. So that's what we're looking at. Probably some spillway expansions or lowering the crest of the auxiliary spillway to gain those capacities, or raise the top of the dam, some measure like that in order to meet this current criteria that these dams fall into.
So, administratively, as far as financially, I don't know what that looks like for West Virginia. Our letters say we have 120 days to respond to the original letter. And at this point, all I got is, we acknowledge your letter, and we're going to work with our partners to get a plan. So that's West Virginia. We have a budget of $3 million. About $1 million we pencil in for just grass cutting and normal maintenance. So we're working on $2 million a year for our repair program. So I think we used all of our time, Ray, but they have, if anybody wants to follow up with questions for myself or Levi, feel free, please do.
Well, let's do a couple of reminders here. One, you've got a question, and two, if you do have a question that you want answered by our panelists, the folks that are presenting today, just pop that into the Q&A area of the Zoom bar there, because that will allow the folks to actually answer those even after we go past their presentation and on to the next one. But hey, here's the question that came in. Do you operate the valves on an annual basis or some frequency?
We do not. West Virginia Dam Safety waived that requirement of us. A few years ago, we had a large multi-function dam that we got a log stuck in, as I talked about the debris load earlier. Could not get the gate closed, drained the lake, a huge financial hit to the local DNR folks. So that we do not. But because of our large debris load, operating gates when necessary is very important to us, because we get risers that are clogged up with our debris loads. So we've had to drain or lower more reservoirs in the last couple of years than the previous 20 years here. So to answer the question is, we do not, and that's because of a waiver from DNR or dam safety, sorry.
Excellent, Gene. Levi. All right, here's your last chance that if you thought of something, oh my gosh, I wish we would have said this to this group of several hundred people that are with us today. What would that be? Anything you would like to say to the group as we close your presentation today?
Oh, from us?
Yeah.
We enjoy the coalition. It's nice for me to see other states having similar problems. I enjoy presenting. I enjoy seeing the other presentations. That's really what I have. Levi?
Yeah, nothing else for me.
Thanks, guys. We really appreciate it. Great insight, great presentation. Thanks so much for your efforts in preparing it and giving it today.